Okay, everybody. So I just wanted to review with everyone how we did practice 5A. I also wanted to go over some notes that you may or may not have missed on Tuesday. And then I want to talk about the homework assignment that's going to be due tomorrow. So Monday we were talking about compounds. And we know that compounds form a couple of different ways. There's ionic compounds, there's covalent compounds. And so first we're talking about ionic compounds, which are of course made of ions, atoms with a charge. And the reason that elements get a charge in the first place is that elements are the most stable when they have the same electron configuration as a noble gas. So for example, sodium, which is in group 1, has one valence electron. It could either gain 1, 2, 3, 4, 5, 6, 7 electrons and get the same electron configuration as argon, or sodium could lose the one valence electron it has and then end up with the same electron configuration as neon. Now, since sodium is a metal, and metals tend to be less electronegative because they're on this side of the periodic table, which has fewer protons, sodium is going to lose that electron, okay? And so, just like all of the elements in group 1, sodium usually is going to have a charge of positive 1. So on the homework that was assigned, 5A, in order to draw the Lewis dot structure of the neutral atom, we find the element on the periodic table, we look up above that element at the A group number, and that tells us how many dots to put on the neutral Lewis dot structure. So sodium, when neutral, will have one valence electron. It is going to lose that one electron and get a charge of positive 1. If it has one dot and loses the dot, then the Lewis dot structure of sodium as an ion is dotless. Anytime we change the Lewis dot structure for an element, we're going to put that element in brackets, and then we're going to put the charge that it has in the top right corner. So I'm going to take sodium, put it in brackets, and put that +1 charge on the outside. Now, since they're losing or gaining electrons in order to have a noble gas configuration, what you should notice about this last column is that all of the ions you draw should either have no dots, like sodium, and those are going to be the positive elements. So all of the ones in group 1 will have no dots, all of the ones in group 2 will have no dots, and they'll have a positive 2 charge. All of the elements in group 3A will have no dots, they'll have a positive 3 charge. Group 4A tends to not make ions because it has 4 valence electrons, so instead it's going to do something called covalent bonding. Group 5A, they're going to gain 3 electrons. Since they have 5 valence electrons, they gain 1, 2, 3 more in order to get that noble gas configuration. Group 6A will gain 2, so they have a charge of -2, and group 7A will have a charge of -1 because they're going to gain 1 electron. These over here, because they're gaining electrons, we should see their ions with 8 dots. So I'm going to go ahead and do one of those. Chlorine is a nonmetal. If I find chlorine on the periodic table, it is in group 7A. So it has 7 valence electrons, and for the neutral Lewis dot configuration, that's what it should look like. Okay, 7 dots. Now, we said that it's going to, instead of losing the 7, it is electronegative. This side of the periodic table has a lot of protons. It's very attractive. So it's going to gain 1 more electron to get the electron configuration of argon. And so the Lewis dot structure, if we gain 1, I simply add that 8th dot on there. Okay, so for the nonmetals, your negative ions, we should see those negative charges, and we should see that their valence shell is completely full with 8 valence electrons. So again, this column right here, the positive ions should have no dots, the negative ions should have 8 dots, okay? So then we know how ions look, but what about compounds, right? We have to start putting things together to form compounds. So first off, let's go ahead and define a chemical bond. So a chemical bond is an attraction between the nuclei of one atom, or the nuclei of several atoms, and the valence electrons of other atoms, okay? And specifically, it's the protons with their positive charge that are attracted to the valence electrons with the negative charge. And that holds the different atoms together, okay? And so it's all about opposites attract. And that is especially true for ionic bonds, okay? In an ionic bond, what we have are elements that have very different electronegativities. Okay? In fact, we can measure the electronegativity of every element on the periodic table. And if the difference between the electronegativities of the elements that are bonded is greater than 1.7, it's going to be considered an ionic bond, okay? And so again, opposites attract. Okay, ionic bonds are going to form when elements from opposite sides of the periodic table bond together, okay? If they have low electronegativity on one side and high electronegativity on the other side, then an ionic bond is going to be a bond between elements that come from different sides of the periodic table. And so what happens is the one with more electronegativity is able to steal the electrons from the less electronegative electron donor, okay? And ionic bonds tend to form because they're from opposite sides of the periodic table between metals. Those are the ones that are going to give up their electrons, and the more electronegative nonmetal elements that gain the electrons. Okay, so what ends up happening is, let's say you have potassium, right? It's in group 1 on the periodic table, and you have chlorine. It's from group 7 on the periodic table. Well, when they bond, what ends up happening is the electron from potassium is transferred to chlorine. So potassium ends up losing its electron and getting a charge of +1. And chlorine gains that electron to fill its valence shell and has a negative charge. And then the opposite charges stick together, and that's how that bond forms. Okay, so it's always going to be the more electronegative nonmetal accepting the electrons, okay? The metals are typically going to be the ones that lose their electrons. And you can tell that a bond is ionic because you have different types of elements. You have a metal and at least one nonmetals, okay? And so the type of bonding that we see here gives ionic compounds some special properties. Cations, which are the positive ions, and anions, which are negative, arrange themselves in something called a crystal lattice structure. And so simply what that means is that your positives and your negatives alternate in a big crystal. So they're connected, and at every point we're alternating positive, negative, positive, negative. Okay, and so it kind of forms this pattern of alternating charges. And since the ions in ionic compounds are charged particles, Solutions made with ionic compounds will conduct electricity. And any ionic compound that does that conducts electricity, is known as an electrolyte. Okay? So ionic compounds generally, when they're in a solution, will have electricity, have the ability to flow through that solution. Because we have the separation of positives and negatives, just like a battery, electricity is able to go from positive to negative and move through the solution. And so they're known as electrolytes because they have that property. And you've probably heard that word before. So, all that being said, on the back of your homework, we kind of have to draw the Lewis dot structures of the entire compound. So first, I look at the compound formula, and I determine what the positive and what the negative is. Now, the positive is generally going to be your metal. If it's positive because it's losing electrons. So we should see no dots. Okay? If it's negative, then it's probably the nonmetal, because those are electronegative and able to accept electrons. And I should see 8 dots because they've taken all the dots. Okay, so KCl, potassium is the metal. Notice that there are no dots, positive charge. Chlorine is the nonmetal, and I'm going to go ahead and draw the electrons on here. Okay, and when I put it together, I'm going to put the positive next to the negative over here to draw the compound. Okay, my dots are a little messy, but that's the way it goes. Okay, so let me do a different one with you. If we look at MgCl2, it's magnesium chloride, okay? We have to determine which one is the positive and which one is the negative. So if we look on the periodic table and find magnesium, magnesium is an alkaline earth metal, and it's in this family that tends to go positive 2. So it lost 2 electrons. It's not going to have any dots, okay? And if we find chlorine on the periodic table, chlorine is in group 7, but it will accept 1 electron to get a charge of -1. And so I'm going to draw chlorine with 8 dots. Okay. And if you notice, here's the thing. Chlorine accepted 1 electron, but magnesium gave up 2. How can chlorine accept only 1 electron if there are 2 being given off by magnesium? Well, that's why there's 2 chlorines. Each chlorine is going to accept 1 electron from magnesium. Magnesium is going to give up 2 electrons, so we need 2 chlorines. So if we think about the crystal lattice structure that we drew in the notes, we have to make sure that we're alternating charge. It's either going to be positive, positive, or negative, positive, but we need to alternate. In this case, since we're going to have 2 chlorines, I'm going to alternate negative, positive, negative. So Cl, -1, magnesium, +2, chlorine, -1. So this chlorine accepted an electron from magnesium, the other chlorine accepted an electron from magnesium, and that's why magnesium chloride always has 1 magnesium and 2 chlorines, okay? Anyway, this is how you finish the back of your homework, and so this assignment needs to be completed and brought back tomorrow.